Welcome to the project demonstration of SOC estimation by using PIC microcontroller along with temperature protection. So here we are calculating and estimating the state of charging of a battery. So that will be displayed on the LCD screen. The state of charging nothing but, so it will indirectly intimate to the person how much of percentage of battery life is existing inside that. And also if is there any high temperature increases, so that will be read by this temperature sensor and provide us the audible alert, and it will isolate the load directly. So when you switch on the kit, the system will check the initial battery voltage and it will store that in a variable, and then after 10 to 15 seconds of duration it will on the load, and from there it will check again the battery voltage. So by using the Coulomb counting method, we are going to calculate the state of charging. So for every load consume the power, then the battery voltage decreases based on the decrement of this battery voltage. If it is drained very fast manner, then the SOC percentage will be decreases, means the quality of the battery. And when it is stay at a low dropping voltage, then it's indication of the battery life is very good. So the battery voltage measured by the microcontroller from the voltage sensor. So that was interfaced at the pin number A0 of our microcontroller. And also for voltage temperature sensor is interfaced at the A1 and the voltage sensor at A0. So based on these two conditions, our microcontroller will calculate the SOC also. Why? Because while the load was connected, if the battery voltage is stay calm and if the battery temperature increases, then it will affect the SOC value also. Means these two are the main input to our Coulomb counting method. And based on that, after time completion of 10 to 15 seconds duration, our microcontroller will switch on this load, which was a 12 volt 1 watt load, so which was connected at the pin number C5 and C3 for this buzzer and LCD for the pin number B2 to B7. So we are providing 12 volts 2 amps. So if you see this battery pack consists of two battery packs. Each battery pack of 3 4 volt 1 amp batteries are in series. So we will get 12 volt 1 amp and 12 volt 1 amp. So these two are in parallel. So we will get 12 volt 2 amp. So but the operating voltage of our PIC microcontroller is 5 volt. So for that purpose we are making use of this 7805 voltage regulator, which will take 12 volts DC input and provide as a 5 volts DC output. Once we provide that 5 volts DC to this microcontroller, it start reading input from the voltage sensor, so from this 10:1 potential divider circuits, and temperature from this temperature sensor. So based on these two values, the system will capture the initial voltage of this battery. After the 10 to 15 seconds time completes, then automatically the load will get switched on with help of this MOSFET board. So then after, the system start calculate the SOC value by comparing the initial values without load and with load. Right. So whenever the temperature crosses the 45 degrees centigrade, then automatically the buzzer will get switched on, as well as the load will be isolated from the battery in order to protect the battery pack. So this is the charging voltage charger for charging of this 12 volt 2 amp battery. So if you want to charge a battery, just connect this 230 volts AC input to the transformer. So this rectifier will, this regulated power supply board will rectify, filter. After these two stages, we will get the 12 volts DC. That is the main charging voltage for our battery. So it will be getting fully charged in a duration of 6 to 8 hours. So once the time completes, you can just isolate the power supply to the charging circuits. And here we can see the on-off switch. So this is the main on-off switch for the whole circuitry. So this is the charging cable from the charging circuits, and this is for the MOSFET to the power supply to the load, and this is the power supply input to the voltage sensor. And now just on the power supply. After welcome message displayed on the LCD screen, there you can see the voltage and current and the temperature. So after the time completes, then automatically the load will get switched on and it start displaying of our SOC values on the LCD. And you can check the temperature value, right? So as of now, the Q nothing but SOC value is 98.2. So when the load time goes on, then the voltage of this battery will be decreases, then we'll get the SOC value also will be changes. So if meanwhile the temperature increases, when it crosses the 45 degrees centigrade, then automatically high temperature and buzzer alerts, and load also will be isolated from the battery. So let us wait for some time whether the battery voltage will be decreases or not, right? So it decreases, so the value also will be changes. So this is the another version of our previous project. So we have replaced the Arduino with our PIC microcontroller.